In previous lecture, we have seen metals and non-metals chapter, short answer questions. And in this lecture, we are going to see metals and non-metals, NCERT, long answer type questions. So long answer type questions, we can expect 5 marks. How we need to understand the question, how we need to write the answer. Let us try to understand it. So question, a non-metal A, which is the largest constituent of air. Okay, some non-metal A, we don't know that. So it is largest constituent of air. Okay, right from 5th class onwards, you have been listening to this concept. There are many gases. So which gases will be in high amount means nitrogen. When heated with H2 in ratio 1:3 in the presence of catalyst iron gives gas B. So nitrogen, when it is heated with hydrogen H2 with the ratio of 1:3 means nitrogen should be 1 part, hydrogen should be 3 parts. It gives that also in presence of one catalyst iron, it gives one gas B. On heating with O2, it gives oxide C. So same nitrogen on heating with oxygen, it gives another oxide C. If this oxide is passed into water in the presence of air, it gives an acid D. So this C, if you take this C and if you pass through water H2O, it gives one acid that is D, which acts as strong oxidizing agent. So we know there is only one acid which acts as strong oxidizing agent, that is HNO3. So this D is HNO3, we can identify. This A, non-metal A is nitrogen that we can identify. Nitrogen plus hydrogen gives rise to ammonia, isn't it? NH3, ammonia. So this B is NH3 that we can analyze. Nitrogen plus oxygen gives rise to nitrogen dioxide, right? So that C is nitrogen dioxide we can analyze. Identify A, B, C, D. A is nitrogen, B is ammonia, C is nitrogen dioxide, D is nitric acid. To which group of the periodic table does this non-metal belongs? So when you study this metals and non-metals chapter, easily you can identify here hydrogen, helium, here lithium, beryllium, from here boron, carbon, nitrogen, oxygen, fluorine, neon. So this is 18th group, 17th, 16th, 15th. So nitrogen belongs to 15th group element. So during periodic classification of elements, I'll tell you how to identify element from group and period. Okay, we got so here A, non-metal A is nitrogen gas. After writing this, underline this, and after writing this equation, you got B. B is ammonia, underline this. Then when that nitrogen heated with oxygen, it forms either nitrogen oxide or nitric oxide, nitric dioxide, something. So C is NO2, nitrogen dioxide. Then when it is passed through water, nitrogen dioxide, when it passes to oxygen, it will be passing through water. It gives acid, that is strong oxidizing agent, that is nitric acid. So D is nitric acid, you underline this. And at last, it belongs to 15th group or 5A group. That is the answer you have to write. Any doubt in this question?
No, sir.
Sir.
No, sir.
Sir, mercury is a good conductor, not a bad conductor of heat, it seems, sir.
Oh, who's it?
Yes, sir.
It is a bad conductor of electricity, sir.
Good conductor of electricity.
But in your textbook itself, it is clearly mentioned. Wait, let me open the textbook. So what your sir said? Mercury is
Bad conductor of electricity, but not a bad conductor of heat.
okay. Mercury is not bad conductor of heat. Your sir said, isn't it?
Yes, sir.
Here, ask your teacher to observe 38th page. Lead and mercury are comparatively poor conductors of heat. So it is given in textbook, isn't it?
Sir, but sir told,
Hmm.
sir, but sir told it is not completely conductor, but it's somewhat conductor.
So I'll tell you the answer is, so lead is comparatively, not only lead, mercury is poor conductor of heat. It cannot conduct heat energy. Definitely it cannot conduct. That is so damn sure. It cannot conduct. But I asked
But
one question,
it,
why mercury is used in thermometers? How it can show temperature? That's it, na?
sir, but it conducts in liquid form, no, sir.
No, here thermometer works with the principle of liquids expands on heating. Not only liquids, metals, isn't it? Metal expands on heating, isn't it? So this you have studied in 6th class, 5th class concepts, 5th, 6th, 7th. So not only metals, liquids also expands on heating, gases also expands on heating. Here mercury works with this principle. Mercury expands when it is heated and contract when it is cooled. That is the principle of mercury in thermometer. Okay. So definitely mercury is poor conductor of heat. There is a huge difference between expansion and conduction. Conduction. Actually, what is meant by conduction? Any idea, guys? If you don't have idea, I'll explain. What is conduction?
Passing of electricity, sir.
Sorry?
Conductor Venus.
What is meant by conduction process? In heat energy, in heat, we are going to get three words: conduction, convection, and radiation.
Sir,
Yes.
conduction means the process which transfers some hot to cool, sir.
Okay. These three words we use for heat energy. I'll tell you. So these three are used to explain how heat energy will be transferred from one to another. So here conduction we'll use for, here I'll explain. If we take one object which is hot and if you take another object which is cool, if you place these two objects very near to each other, this is cool, this is hot, and if you place very near to each other, when it is sticking, if it is sticking, then heat energy transfer from one body to another body, one body to another body. So this is another process. First I'll tell conduction. If you do dosa, if you observe dosa, if you will keep dosa pan on the burner, na, so that burner will be very small, and if you observe that dosa tawa, it will be very big. So that dosa tawa you'll be keeping on the burner, and if you observe that burner will produce heat energy only at this point in the middle, but after some time you can observe, if you touch here you'll get hot, if you touch here it will be hot, if you touch here also it will be hot. How come? Not only that, if you see the same example here, same example, this is iron rod. So after taking this iron rod or some metal rod, stick some wax and keep one iron nail to it. Here you are supplying heat energy in the same body. If you are supplying heat energy is transferred from one point to another point of the same body. If heat energy is transferring from one point to another point in same body, that is known as conduction. Try to understand. Conduction is the method where we are using if heat energy is transferring from, moving from, passing from one point to another point in the same body. So same thing is happening in dosa tawa also. Though that burner is in the middle, that heat energy is transferred. How? In the sense, for example, if you take this rod, there will be molecules, atoms, right? If you heat at this point, at one end, this molecule, this atom will get heat energy and it will start vibrating. That vibration is carried to another molecule, another atom, that also will start vibrating. Another, that also vibrates. It vibrates like that. Because of the vibration, that heat energy is carried from one point to another point in the same body. That is conduction. Next one is convection. I said convection, if heat energy is traveling from one body to another body, that is known as convection. One point to another point, conduction. One body to another body, it is convection. Then if you see, there will be a campfire and fire will be there. If you place your hand near to this campfire, you can feel that heat energy, isn't it? Not only that, sun will be here, earth is there here. From sun, we are getting light as well as heat energy. Means if heat is transferred from one place to another place, that is known as radiation. So conduction means one point to another point. Convection means one body to another body. Radiation means one place to another place. Like that,
Yes,
heat
sir.
will be transferred. Now, while coming to that mercury, mercury is poor conductor of heat. Yes, but metal expands on heating. In 6th class, 7th class, you might have studied. If you see bullock cart, there will be tire of the bullock cart. For that bullock cart tire, there will be iron rim. Did you observe?
Yes, sir.
In villages, how can you fix that iron rim? So that
By heat.
that iron rim and bullock cart wheel will be in the same diameter and radius. If you heat the trim, it expands, then they will fix it, then it will be cooled automatically. It will be sticking to the outer part of the wheel. So metal expands on heating. So why there will be gaps between railway tracks? Did you get this question in your CBSE textbook, NCERT? In 8th class, 7th class, I guess. Why there will be a small gaps between railway tracks? Because sunlight falls on that railway track, which is made up of iron, there will be uneven expansion. So that when there is a gap between railway tracks, what happens during sunlight? That
Automatically it expands.
expands. So when there is expansion, there will be no, it will be straight. Railway track will be straight. If there is no gap, do you know what happens? That railway tracks, it becomes like this. So there will be uneven expansion like this. When there is uneven
Yes, sir.
expansion, that leads to accident. If you can observe, from one electric pole to another electric pole, wire will not be straight. Wire will be sag like this. In summer, wires will be sagged. In winter, it will be straight. Why? Because sunlight falls on the wire, it expands. Now you tell, mercury is good conductor of heat or poor conductor of heat?
Poor conductor.
Yes,
Good
it is poor
conductor.
conductor of heat only. It is not good conductor. It cannot conduct heat energy. And how it works in thermometer? What is the logic?
Expansion of
Liquids expand on heating, sir.
Very good. So we
expansion
have
of
to
metal.
learn concepts very correctly. Then next question. Give the steps involved in the extraction of metals of low and medium reactivity. It is quite simple. So if it is low reactivity, we can go with roasting. Sorry, here you see low and medium reactivity they are asking. So for metals, low reactivity like mercury, following steps are involved. So low reactivity you can take like mercury, copper, silver sulfide, copper sulfide, mercuric sulfide. You can go with either roasting or calcination. So first we will go with roasting. So when metal sulfide, it is heated in presence of oxygen, we are going to get metal oxide and some sulfur dioxide gases. It will be evolving out. Again, we will take this metal oxide here. Take metal oxide, then we will heat in absence of oxygen. When you are heating in absence of oxygen, what we can do? You can remove oxygen from metallic oxide. But you might ask question, sir, we can heat in presence of some coke or charcoal something. That is reduction process, right? So roasting, so here calcination, reduction, there is a huge difference between reduction and calcination, right? So if you want to go with reduction, what we have to do? We have to add something extra, coke, something like this. So that oxygen will be removed and added to. So oxygen should be removed from one element, should be added to another element. That is reduction. Okay, then we are going to get metal and oxygen. Then while coming to high reactivity, we are going with refining of metals. So for metals of medium reactivity, so for high, medium, low is there. For low, we can go with roasting. For medium, you can go roasting as well as calcination. And for high reactive, electrolytic refining process we are going, isn't it? Electrolysis. Then, so roasting, then reduction and calcination and reduction. So you can write either way. So this simple chart you can remember. For low reactive, roasting, medium reactive, roasting and calcination. Again, after doing roasting and calcination, it will be converted to metal oxide. Again, that metal oxide, what we can do? We can go with reduction process. After reduction process, we are going to get metal. That metal, what we will do? We will do refining like that. Next, explain the following. Reactivity of Al aluminum decreases if it is dipped in HNO3. Yeah, HNO3 is an oxidizing agent. When aluminum is dipped in HNO3, oxide layer of aluminum is formed on the surface of the metal, which prevents it from further reaction. Aluminum is known as self-protecting metal, na? So that when oxygen is added on aluminum, if it is deposited on aluminum, so entire compounds will be deposited like this. Hence, it prevents from further oxidation, so that reactivity will decrease. It will not allow for the reaction. Next, carbon cannot reduce the oxides of sodium and magnesium. Sodium, magnesium, etc. metals are quite reactive. They are high reactive, na? And present towards top of the reactivity series, right? Hence, their affinity of oxygen is higher than carbon. Therefore, those oxides, sodium oxide, magnesium oxides, are stable. To reduce them with carbon with high temperature is required. So it is not that much possible to, for example, you got Na2O, sodium oxide, high reactive. It is not at all possible to remove oxygen from sodium. To remove what is required, very high temperature is required, and the temperature will form their corresponding carbonates, and hence oxides cannot be reduced from carbon. So it is not at all possible. For example, Na2O plus carbon gives rise to nothing. No, it is not possible to remove oxygen and add to carbon. But if it is something like ZnO, zinc oxide plus carbon, yes, we can remove oxygen and we can add to carbon. Then we are going to get zinc plus carbon monoxide. That is the process of reduction. Next, NaCl is not conductor of electricity in solid state, whereas it does conduct electricity in aqueous solution as well as in molten state. Yeah, NaCl is ionic compound, isn't it? So so ions of NaCl cannot move or carry the charge in dry state, because in dry state all ions are tightly packed. That is the thing where we studied in 9th class, na? Matter in our surrounding. So if we take first chapter, second chapter, chemistry of 9th class, we studied in solids, all molecules are tightly packed. In this tightly packed, it cannot conduct. The ions cannot move and it cannot carry. So conduction cannot happen in sodium chloride, not only sodium chloride, in ionic compounds, as they are fixed. But they are free in molten state and in aqueous solution to carry the charge, and hence NaCl conduct electricity in molten state. In liquid state only ionic compounds, nothing but salts, will conduct electricity. Iron articles are galvanized. Yes, Iron, when it is reacting with the moisture and air, oxygen present in atmosphere, automatically layer is formed, and that is known as rust. To prevent from the rusting, we are in galvanization, layer of zinc formed over iron by dipping them in molten zinc. They will take iron articles in molten zinc, just they will dip and they will remove. Automatically, zinc will be coated on iron, which prevents iron from corrosion. This is important. Prevents iron from corrosion. Zinc is more reactive than iron. When though it is formed, what happens? Though zinc also, it can react with oxygen, guys. It can form a layer, but zinc, aluminum, these are self-protecting metals. So that what will happen? Though, for example, you see this is iron, and on this iron, zinc coating. For example, this is zinc coating on iron. Again, if this zinc is reacting with oxygen, for example, this is oxygen, let us guess. So this oxygen, when it is reacting with the zinc, it stops here. It will not allow zinc for further oxidation, self-protecting metal. Next, fourth one. Fifth one, metals like sodium, potassium, calcium, magnesium are never found in free state in nature. Yeah, they are high reactive metal. They never found in free state. Are always it is found in some compounds. So these metals are quite reactive, so they cannot exist in free state. Hence, they are found in nature in the form of their compounds. In compounds only they are found. It is not like silver and gold, platinum, just extraction, removing the dust and using. It is not possible. Any doubts in this?
No, sir.
Right. Then try to observe this
No
question.
doubt.
Try to observe question and answer. Given below are the steps for extraction of copper from its ore. Write the reactions involved. Okay, they're extracting copper. Roasting of copper sulfide. So first we are getting copper in the form of copper sulfide. So copper sulfide is taken. Roasting means heating in presence of oxygen. So copper sulfide plus O2, oxygen gives rise to, if it is heated, we are going to get metal oxide plus sulfur dioxide. So roasting means heating in presence of oxygen. Now, reduction of copper oxide with copper sulfide. So second one, reduction of copper oxide, this Cu2O we got na, take this Cu2O and add copper sulfide to it, so that reduction process can be observed. You can remove oxygen from this copper and add it to this sulfur, so that we are going to get sulfur dioxide gas and copper is extracted. Then electrolytic refining, right? Electrolytic refining means we know this one. So we have to take beaker in which there will be anode, cathode, and electrolyte. So these three are important. In near anode, we have to take impure copper, thick block. So impure copper will be very thick block. And while coming to cathode, very thin strip of pure copper. Electrolyte, salt, any salt of copper content. Now, so you see what they have given? A thick block of impure metal at anode, a thin strip of pure metal at cathode, copper sulfate solution taken as electrolyte. Next. So that next, is there anything question in this? B. Draw a neat and well labeled diagram for electrolytic refining of copper. This is the diagram. They didn't ask you to explain. No need to explain anything. Done, but you have to draw. Positive, nothing but anode, impure copper. Negative, nothing but cathode, pure copper strip, battery with positive and negative terminals. And after reaction, we will get anode mud, that is impurity. The solution is copper sulfate. Everything you have to mention. Next, of the three metals, X, Y, Z, X reacts with cold water, Y with hot water, and Z with steam only. Identify X, Y, and Z and also arrange them in order of reactivity, increasing reactivity. Guys, if you observe metals with water, right? So in this concept itself, you can get all the answers. So 3.2.2, what happens when metal reacts with water? So these are the things you have to read. Here they might have given potassium, sodium reacts violently with cold water, and calcium with less violent. Magnesium does not react with cold water, but it reacts with hot water. And zinc, iron, zinc do not react with cold or hot water, but they react with steam. From this, you can extract answers, isn't it? Now, that X is sodium. It reacts with cold water. Magnesium reacts with hot water. Iron or zinc reacts with steam. Done. Like that. From textbook only, we can get read textbook very properly. And according to reactivity series, iron is less than magnesium, less than sodium. Or you can write of increasing reactivity, sodium is greater than magnesium, greater than iron. Like that also you can write. Both are correct way. Then any doubts in these two? If you have doubts, you can ask. I'll clarify it. Right.
No, sir.
Pranati, Amin, Pritika,
No, sir.
Likit,
No doubt, sir.
done.
No doubt, sir.
An element A, we don't know what is that A, burns with golden flame in air. Golden flame in air. It reacts with another element B, atomic number 17, to give product C. Atomic number 17, that is a logic, that is chlorine. So that A reacts with chlorine to form C. Okay. An aqueous solution of this product C on electrolysis gives compound D and liberates hydrogen. So if you take that to C, and if you do electrolysis, that's what na, an aqueous solution of C on electrolysis gives compound D. Okay, so that C, if we add it with water, we are going to get one D, it seems. D and liberates hydrogen, D plus H2. Identify A, B, C, D. Also write down the equation for the reactions. Okay. Element A burns with golden flame in air. Golden flame in air in the nothing but that indirectly they are talking about fire. Fire will be yellow, golden yellow, na? So that A is sodium because it burns with golden flame in air. So we got A. So that A, here what they give? It reacts with another element B, atomic number 17. That A should react with B, that B atomic number is 17, so that is chlorine. So sodium reacts with chlorine to form NaCl. That is done. Forms a product C. So now that product C is NaCl and B is chlorine. These are the things you have to underline, guys. A is sodium, B is chlorine, C is sodium chloride. An aqueous solution of product C. This C we got NaCl. So NaCl and water. That is nothing but brine solution. Na? In where did you learn this brine solution? In acid, bases and salts. That is the interrelation. It gives of electrolysis. It gives product D. Done. We got that NaOH as well as hydrogen gas. Of course, chlorine gas is also produced. So like that you have to write the answer. Then 2 ores A and B were taken. Okay, there are 2 ores we don't know. On heating, ore A gives carbon dioxide, ore B gives sulfur dioxide. What steps will you take to convert them into metals? Right. When it is giving carbon dioxide.
This question we got in cycle test, sir.
Sorry?
This question we got in cycle test.
Oh, very good. That's what they won't get. Teachers cannot. I am also telling. If I want to give any question, I cannot get any question from my own brain or something. We have to extract questions from either in text or exercise or exemplar or previous year questions. That is the source. In your board examination also, that is the source. Whenever you are seeing carbon dioxide, just you can go with carbonate because carbonate. Carbonate means you can go with calcination process. And SO2 means sulfur. So we can go with roasting process. Simple. What all we have studied. So ore A gives CO2. So it must be carbonate ore, and we have to moderately react to metals like zinc. They are. So we have to convert that carbonate ore. We have to heat in the absence of oxygen, so that we are going to get metal oxide and carbon dioxide. Then again we have to take that metal oxide and heat in presence of carbon, so that we have to go with reduction process. That also you write. This is reduction process where we can get metal. If it is sulfide ore, take metal sulfide and heat in presence of oxygen, we are going to get metal oxide plus sulfur dioxide gas. That process is known as roasting. Again, what we can do, you can take that metal, all these examples, zinc sulfide, copper sulfide, hydrogen sulfide, in all these cases we are going to get metal oxides only, and you take all metal oxides and heat in presence of carbon, or you can take in presence of copper oxide, metal oxide. So metal sulfide you can take metal oxide, so that we can go with either these two processes are known as reduction process. There we can extract metal, here zinc metal and copper metal. So don't get confused. If it is sulfide ore, we have to go with roasting. Sulfide ore, go with roasting. If it is carbonate ore, we have to go with calcination, like that. So these are long answer questions. So once again, if required that metals, I'll tell you. You see, metals, three categories. Here, high reactive metal, moderate reactive metal, least reactive metal. While coming to least reactive metal, that metal will be in form of metal sulfate. If you are having metal sulfate, you have to go with roasting process. What is roasting process? Metal sulfate, you have to heat in presence of oxygen. So you have to heat. If you heat, what happens? That will be converted to metal oxide and sulfur dioxide gas is produced. Again, you have to take metal oxide, and you can take any X element. You can go with, you can extract metal plus that XO can be taken out, which is nothing but reduction process. And again, after doing reduction process, you can extract metal. And what you have to do with that metal? That metal you have to go with refining process. That's it. That is about low reactive. Well, coming to moderate reactive, you can find either in form of metal carbonate and metal sulfate. So if it is metal sulfate, go with this method. Same will continue. If it is metal carbonate, so you have to take metal carbonate, just you have to heat it. If you heat in absence of oxygen, you can get metal oxide plus carbon dioxide gas. Again, take that metal oxide, same process from here. Add some metal sulfide or some X compound or element, so that oxygen can be added to this X. We can get metal plus XO. So that is known as reduction process. Here this process is known as calcination. This is calcination process. This is reduction process. Again, after going with the reduction, we can extract metal. After taking that metal, you have to go with the process called refining. Next, high reactive metal, you have to go with electrolysis, electrolytic, right? Electrolytic refining, electrolysis process you have to go. So again, while coming to that, in that we have cathode, we have anode, and we have electrolyte. Now, while coming to cathode, cathode means it is negative terminal. Anode means positive terminal. Electrolyte means it is solution. What solution? It is salt solution. While coming to negative terminal cathode, we are going to take pure thin strip of required metal. Pure thin strip of required metal. Anode, we are going to take thick block of impure metal. And electrolyte we are going to take salt solution of that required salt. That's it. So this is extraction of metals. Any doubts in this chapter?
No, sir.
So today, please read textbook. Once you revise this textbook, all contents. So tomorrow, I mean in next class, we are going to see MCQs. Previous year MCQs as well as conceptual MCQs, nearly 60 to 70 MCQs we'll try to cover. So here we covered textbook concepts, in-text questions we covered, exercise questions, NCERT exemplar. This is more than enough to acquire knowledge. Now with this knowledge, we are going to see MCQs. So for that, at least spend 30 minutes today to read textbook concepts, physical properties of metals, chemical properties of metals. In this chemical property, reaction with oxygen, reaction with water, reaction with acids, reaction with bases, reaction with salt solution, then this reactivity series. After that, how do metals and non-metals react? That is regarding ionic compounds. How, what will be losing electron, what will be gaining electron, I have to learn. Then properties of ionic compounds, and these properties are most important. Then occurrence of metal, how to extract metals. So this is a chart what I have told. So this chart is most important. Then enrichment of ores, what is meant by ore, what is gangue, what is mineral, what is metal, you should have some idea. Then low reactivity series, how to extract. Medium reactivity series, how to extract. What is the thermit reaction, all these reactions you have to read. Then extraction of top of the reactivity series, what is electrolytic refining. At last, corrosion. In chapter 1 itself we got that corrosion and preventions of corrosion. That's it about this chapter. Then you see what we have learned. These all concepts also important. If you have any doubts, you can clarify tomorrow also, or if you have doubts, you can clarify now itself. If you are done, you can leave. If you have doubts, you can stay and ask me doubts.
Thank you, sir.
Thank you. You are free to leave or you are free to ask.
Sir, in the extraction of ores, we have to write all the steps continuously, sir, for the board exam. Or if we miss something,
Depending
then
upon mark.
we may
Depending upon mark.
lose.
If it is 5-mark question, yes, you have to write.
Actually, in the cycle test, I have missed some lines, so that I don't know how much I got in that.
You see how many marks, for how many marks they ask that